So for this video, I decided to do something a little different. I'm just looking at section 4.4 in the book. I've already posted at least one video on content from 4.4. The video where I talked about how to convert decimals to fractions and fractions to decimals. Especially like the more interesting ones are the decimals that repeat. So any decimal that terminates or repeats can be written as a rational number. So I showed you how to take a decimal that repeats and change it to its fractional equivalent. So I did that in another video. But what I'm going to do right now is this is why this is a little bit different video, is I'm going to just look at section 4.4 and see if there's something else I want to talk about from 4.4. A lot of the stuff from 4.4 is just about decimals, like how to add decimals, ordering decimals, which I talked about how to order rational numbers. Well, obviously, most of the decimals that they talk about, most of the numbers that they talk about in the book, they have decimal representations, are ones that terminate or repeat. So you could always just change the decimals into fractions or rational numbers and then order them that way. That's actually what they do. They change them into fractions, at least in a couple of questions. They talk about rounding, which I'm not going to go over. Pretty self-explanatory. It's in the book. Plus, if there's videos on the Cengage website about that, and if I ask questions about that in the homework, I'll link the videos if I can figure out how to do that, which I think I can. I'll link those videos right into the homework. It's something that most of these videos that I make are they have the purpose of trying to make sure I stay in the video. I know you like to see me. I'm trying to make sure I give you the information that I'm trying to convey is the most important, because there will be questions on the final exam. Okay. I know I'm not going to ask you on the final exam how to round a decimal. Now, I still might ask you questions on the homework, but if I do that, like I said, I'll probably try to link, if there's a video that talks about rounding on the Cengage website, I'll link that to the homework. And there probably is, but even if there isn't, you do have a textbook, and I'm looking at it right now, and it does talk about rounding. But know that there probably will not be, if I don't actually make a video or talk about it, there probably won't. That means I don't think it's the most important thing to talk about, and there probably would not be any questions on a test that I give you that deal with rounding. So it talks about addition, addition, subtraction, multiplication, division with decimals. I can do one of each type and just give you like a little insight on how to do it. So adding decimals, there will probably be a video on Cengage about this too. Feel free, I mean, if I link the video to the homework, watch those videos. It would probably be easier for you to watch those videos than watch my videos, since if I link them to the homework, as soon as you open the homework, you'll see them. They're right there for you. You don't have to go anyplace else to watch a video, but watch my videos too. Alright, so let's say we have 7.83 plus 84.729. I'm making this more complicated than it probably needs to be, but I'm doing that for a reason. If you were to add these two numbers together, by hand, not on a calculator. Obviously on a calculator you just punch them in and hit equals. But if you were to add these together by hand, it's common to write the bigger number on top. Then what you have to do, and this is the only thing that's really different from adding regular integers together than, well, actually you have to do it when you add integers together too. But what you have to do is you have to make sure you line up the decimals. That's the only thing you really have to do. You cannot do this. You can't say, right? You can't do it that way. That's not going to give you the right answer. So when you add decimals, you have to line up the decimals. In other words, the 7 goes here, the decimal goes there, right? That's what I mean by line up. And then there's not another number here, so you can go like that if you want. So then it's just like adding numbers, which we talked about before. Just add the 9 to the 0, 2 plus 3, 7 plus 8 is 15, so you put the 5 here, carry a 1. 1 plus 4 is 5, plus 7 is 12, so you put the 2 here, carry the 1. 1 plus 8 is 9. Then the decimal's right here. So, what you should gather from that is it's just like adding integers, but you have to make sure the decimals are lined up. Same with subtraction. Matter of fact, I won't even do a subtraction problem. You do it the same way. Just have to make sure that the decimals line up. Once you have it written that way, where the decimals line up, you just do the addition or subtraction in the normal fashion. Alright, so multiplying, when you multiply you really don't have to line up the decimals, but it's pretty, do I want to say it's normal too? Nah, I don't think you really, let's see, I'll just do an example. I guess it's pretty normal to still line them up, but you don't really have to. Let's see. Let me see if I'm right. Let's see if they have a good example in the book. 3.2 times 2.6. Alright, so this one they just normally line up anyway, because they have the same amount of digits and the same amount of digits after the decimal. So, as a matter of fact, let me change one of them. You guys would be so mad at me if we were in class right now and I erased something that I had written down. Let's just add like a digit to one of these. I can get the top back off of it. So I just added a 1. I'm trying to see if you really need, now see, you really don't need to line up the, you don't need to line up the decimals when you multiply, really. So what you're going to do when you multiply decimals is you're going to basically pretend, I always use the word pretend, even though it's probably not the correct word to use. Imagine is probably a better word, but you're going to ignore the decimal, I guess you could say. Just multiply 321 times 26. Forget the decimal while we're doing it. So 6 times 1 is 6. So you could actually do this using the lattice method if you like that, but I'm going to just do it the standard algorithm way. I think I've done enough air quotes for one video. 6 times 1 is 6. 6 times 2 is 12. So I'm going to go and carry the 1. 6 times 3 is 18 plus the 1 is 19. Now you have to put a 0 there because we're going to multiply by 2, but this 2, well in this case the 2 really is a 2, but we're pretending, remember, that the decimal's not there, so this is 321 times 26. That would sort of be like in the tens place. So we're really multiplying by 20, sort of. I almost did air quotes there, but I said that I've done enough air quotes. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Add these together, 6, 4, carry the 1, 8. Okay, so if you didn't know what the rule was for putting the decimal back in this number, because it is going to have a decimal in it, because these did. If you didn't know what the rule was for that, you could probably figure out what the answer should be anyway, okay? Would 83.46 make sense? Would it make sense to put the decimal here? I'm going to write the decimal here. It's not where it goes, but I'm going to write it there. I'll use green to show that it's not really there. Even though green usually means good. It doesn't today. So, does that make sense? 3 point something times 2 point something equals 83 point something? No. That decimal does not go there. What about that? That makes even less sense. 3 point something times 2 point something equals 834 point something? No. What about, and this is kind of giving away what the answer is, because I'm going back to black pen marker. 8.346. That makes sense. This number is almost 4. That number is a little bit more than 2, or I guess it's quite a bit more than 2. I don't know. Depends on how you think about things. So the answer being 8 point something makes sense to me. So that is the answer, 8.346. How did we get it though? Well, what you do is you look to see. Remember, we pretended that the decimal wasn't there. We just basically did this. Okay, well, we pretended that the decimal weren't there. We just thought this number was 321, which means the decimal would be right there, because, you know, you could write it like that. Same with this. Okay, well, what happened is we're really trying to see what 3.21 times 2.6 is. So the decimal has been moved 2 spots in 1 spot, okay? So a total of, 2 spots here and 1 spot here. That means you have to move the decimal 3 spots here. 1, 2, 3. So I'll go over that again, because the way I just said it makes sense to me, but probably doesn't make sense to somebody that's not me because of the way I described it. Let me flip this over again. So we did this. We just ignored the decimal, and we got 8.346. Well, there really was a decimal here and here. Well, really it was here and here. But we did it without the decimal. But we have to go back and go 1, 2, and 1, which means 1, 2, and 1 is 3, so 1, 2, 3. Okay, I basically just described that the same way that I did before, and said I needed to explain it better than I explained it the same way. That makes sense to me though. If it doesn't make sense to you, let me know. But I think what I said first actually makes the most sense. And that was just, you have to have number sense, which it does talk about too in the book. Okay, matter of fact, it probably talks about that. It does. It talks about that in the next page. Because you have to have common sense. That way also when you, if you figure out a lot of your math problems just by using a calculator, you know if you punch something in wrong, if you have sense, like number sense. Matter of fact, in the last week or two, I've used my calculator probably more than I have in any other 2-week period of time. And And I've also used my calculator on my cell phone, and there's like a glitch in it. Like a lot of times when you hit a certain number, it doesn't type in. So I won't watch what I'm inputting, and then I'll hit equals, and I always know that I must not have inputted something right, because I'll get an answer that doesn't make sense. Well, the answer that makes the most sense, if you ignore the decimals and get this answer, like I said, it doesn't make sense that the answer would be 834.6. It doesn't make sense that the answer would be 83.46. It doesn't make sense that the answer would be 0.8346. The only thing that makes sense is that the decimal would be right there. Okay, so even if you didn't know the rule that you have to count how many times it's moved, so it's been moved a total of 3 times, so you have to move it 3 times. Even if you did not know that, then the only answer that really makes sense is 8.346. Okay, so let's see, what else? Like I said, I did a addition example. Subtraction example would be the same. When you do addition and subtraction, you just have to line up the decimals and then add and subtract as normal. Multiplication, you don't really have to line up anything. You ignore the decimal and then figure out where the decimal goes in the answer. Division. Man, we could do a division problem. I know you'll be mad at me if I don't. If you've been watching the videos, which I think a lot of people probably have been. I don't know how I know that, but seems like it probably is true. Alright, let's see. How do I want to explain this? Once again, I'm looking at it in the book. I don't want to do the exact example that they have in the book. One of my favorite examples, I think I talked about it in your class, or I know I've talked about it before, was one day when I was getting gas somewhere, and I wanted to figure out, like I had a certain amount of money, and I wanted to figure out how many gallons of gas I could buy based on what the price of the gas was. So I had $20. My life savings, and the gas was like, I don't know, $2.30 a gallon at the time. That's probably pretty close to the truth. So I want to know how many gallons of gas I could buy. So, and this was like I was at a gas station. This is a true story. The only thing I don't know for a fact, I can't remember what the price per gallon of gas was. But I do know that I did have my life savings with me, $20, and the gas did cost something. It wasn't free. It was probably about that. So to figure out how many gallons of gas I could buy, I had to do 20 divided by 2.30. You don't really have to put the 0 there. They talk about that in the book. Like, when do you have to put a 0 in a decimal? Pretty obvious, I think, but if you don't think so, you can read about it. So I had to do 20 divided by 2.3. Okay, well, like I said, I'm at a gas station. I think I can put my book on right now. There are other things I wanted to talk about today, but I don't think I'll make a video about square roots or exponents because, well, I might, but I won't put it in this video. I'll have to make a totally different video. This video is already gone. It's going to go over 20 minutes, which I don't like to do. That way, if there's an error in the video, I just wasted 20 minutes of my life. Plus, I think you're less likely to watch them if they're too long. You know, you can watch them sped up, though. It's kind of fun. I watched one of mine the other day on 2x speed. It was pretty hilarious. All right, so I was at a gas station. So I didn't have like you know, I always talk about how I like to do things without a calculator, but I didn't have like a pen and a paper with me. So I was gonna just use my cell phone as a calculator. Now this was before I got my new iPhone. I had an old burner phone type thing, and I don't know if I just didn't know how to do it or if it didn't have it on it, but I couldn't figure out how to put a decimal in it. So I was like, oh, I guess I can't figure out how much gas I can buy. So this is how you'd write 20 divided by 2.3, 20 divided by 2.3. I was like, well, I guess I'm not going to be able to figure out how much gas I can buy. Now, I know you can estimate pretty good, right? About 8 gallons, right? Because 8 times this would be right about that. So I could estimate how much I would buy. I wrote it on my hand. I could estimate, but I wanted to know exactly how much. I was like, crap, I can't do that because my cell phone doesn't have a decimal. Then I was like, wait a minute. I'm a math teacher. I should know how to do this. Well, without a decimal, you can just multiply each of these by 10. Okay. Why did I multiply by 10? I'll give you a minute to think about that. Pause the video if you want. Why did I multiply by 10? Well, the reason I multiplied by 10 and not like 100 or 1,000 is because that's all I need to multiply by to get rid of any of the decimals in the problem. Since this only goes to the tenths place, multiplying by 10 will get rid of that decimal. Now, if gas had been $2.35 a gallon, and I wanted to do this, then I would have to multiply by 100. And the reason there that I had to multiply by 100 is because this goes to the hundreds place, so to get rid of the decimal I have to multiply by 100. Okay, but let's go back to this problem. Well, now I could do it on my calculator because my calculator, or my cell phone, I knew how to enter numbers and how to divide, but I just couldn't figure out how to put the decimal. But let's say I didn't have a calculator. Well, we already talked about how to divide two numbers, so once you get to this point, you're good. So that's how you divide decimals. You change it into a division problem that doesn't have decimals in it, and then you just divide using the standard algorithm. Obviously, or like we talked about, you could scaffold actually. Let's do that actually. Let's finish this problem and then the video will be over, and I might make another video about exponents, square roots maybe, but I might not. I'm gonna go home and I know that there's videos on the Cengage website about exponents and square roots. So what I'll probably do is link those, because if I don't make a video today, I'm probably not coming down here tomorrow, and I'll probably assign homework on Monday, so I don't think I can make another video today. My voice is kind of going out. So I'm going to do this 200 divided by 23. Remember, it's the same as 20 divided by 2.3. I just changed it to this. It's the same problem. Let's scaffold. So the reason to scaffold is just because I think it's fun. I'm going to guess that 5 goes in without going over. Plus this is good review, right? 3. $23 won't go into 16. So you add up these numbers, you get 8. Remember I said that I thought it would be about 8. Right? And then the remainder is 16 over 23. Now, obviously then you'd have to figure out what 16 divided by 23 is a decimal. Because most people don't think of gas as like, oh, it was, or how much gas they could get is 8 and 16 over 23. This is more than a half. So it's a little bit more than 8.5 gallons. So that's how much gas I could buy that day. Now, like I said, I used a calculator to do this when I was actually at the gas station. My only revelation was that you didn't even have to have the decimal button on your calculator to do it. Okay, so this video has gotten way out of the time limit that I usually normally like. So it's over 25 minutes. So watch for more videos, or at least for Cengage videos. And I might try to do a video about exponents, but probably not today.